So I'll go on and record this here, but we can look at a few of these here from the homework assignment. Now, let's see here. Grab from. Okay. So, again, so 9 through 42, looking at any of those there, which one looks like it'd be interesting to kind of work out? Because we can do one from each to. So is there one in 9 through 18 that y'all want to look at or think would be interesting to see worked? Because I can tell you 15 through 18 aren't going to show up on the midterm. We're not going to do those kind of proofs or verifying. Cosine squared of beta minus sine squared of beta equals 2 cosine squared of beta minus 1. So we need to get the left side to look like the right or the right side to look like the left. Well, we know on one side we only have cosine, we don't have sine. So it might be easier to turn this sine squared into cosine. And we know that cosine squared of beta plus sine squared of beta is equal to 1. Which means that sine squared of beta is equal to 1 minus cosine squared of beta. So we can go on and replace that and say cosine squared of beta minus, here, 1 minus cosine squared of beta, and we have this here. And again, since we're doing a proof, we're trying to make the left side look like the right, we don't have to put the equals and write it all the way out. As long as we can get it to look like the right side, we're good. Now with the negative would distribute, so we'd have cosine squared of beta minus 1 plus cosine squared of beta. Cosine squared of beta plus cosine squared of beta is 2. Cosine squared of beta minus 1. And we're done. Some of these here look harder than they seem, and they work out quite nicely. Interestingly enough, 13 works out the exact same way, but instead of replacing sine squared, we would replace cosine squared and get the same answer. Any other ones of those that y'all want to look at? If not, we can look at something from 19 through 24. We can look at 19. One plus tangent of x. So 1 over tangent of x plus 1 over cotangent of x equals tangent of x plus cotangent of x. So this is what we're starting out with here. There's different ways we can go about this. What's one way y'all want to try? I mean, when I first look at this, I think of sine and cosine, yes? So what we could say is that tangent is 1 over sine of x over cosine of x. 1 over, this would be cosine of x over sine of x. Well, when we have 1 divided by this here, really we're just flipping it and multiplying it by 1, which just tells us that I have cosine of x over sine of x, yes? Well, cosine over sine is cotangent of x plus tangent of x, which is just tangent of x plus cotangent of x like we wanted, yes? Questions on this here? What is cotangent of x reciprocal function? Cotangent, yes, because tangent of x is the same as 1 over cotangent, yes? So what would 1 over tangent be? And 1 over cotangent is, then we could switch them and just say yeah, and when I first looked at this or did this one, I went with sine and cosine first. But looking at it this morning, I realized, well, yeah, we could just flip it because 1 over tangent is cotangent. 1 over cotangent is tangent. We're done. Any others? Really, any others on that page? And I'll tell you if there's no reason to look at them. 21. Yes. So 1 plus sine of theta over cosine of theta plus cosine of theta over 1 plus sine of theta equals 2 secant of theta. And secant of theta is the same as 1 over cosine. So we'd have 2 over cosine of theta is really where we're trying to get to, and then we can go to secant. Now for the left side, we're wanting to add these two together, but be able to add two fractions together, the denominators have to be the same. So for the one on our left and the one on the right, we're going to have to multiply both of them by something so that the denominators are the same. Well, for the one on the left, I know I'm going to have to multiply top and bottom by 1 plus sine of theta. And on the right, I'm going to have to multiply top and bottom by cosine of theta so that the denominators are the same. Now again, so to get 2 secant of theta, we're really, again, hoping to have just cosine by itself on bottom, yes? So there's not a whole lot of reason for us to multiply these two out, to actually distribute the cosine. So what I'm going to do is leave it as cosine theta times 1 plus sine of theta. Cosine theta times 1 plus sine theta. Because again, as long as the denominators are the same, we can add or subtract them. I don't have to distribute that out. And what we're hoping is that on top, everything will simplify for the most part and leave us with 2 times 1 plus sine of theta. Because if I have 1 plus sine of theta on top and bottom, they will cancel, and this will simplify out for us. Now, unfortunately, we are going to have to distribute the numerator so that we can add the two numerators together. Well, 1 times 1 is going to be 1 plus sine of theta plus sine of theta plus sine squared of theta. So if we went on to just distribute it, 1 plus sine of theta, we would get this here. For the other one, cosine times cosine is just going to be cosine squared of theta. Questions on any of this here? Now the nice thing with this is that we are just adding. So the denominator will be cosine of theta times 1 plus sine of theta. Now the numerators we can go on and add. So we'd have 1 plus 2 sine theta plus sine squared theta plus cosine squared of theta. In algebra 2 and algebra 1, we would have simplified the numerators, then added them together. But I feel like at this point, combining like terms and adding the two numerators, we can do that all in one step. That's not too big of a stretch for us anymore. Now the next kind of thing is looking at this here. Well, we need to simplify, yes? And it looks like we've got more than just 2 times 1 plus sine of theta, yes? But do we have any of our trigonometric properties here? We have this here, don't we? Because what is sine squared plus cosine squared? 1. So this, all this right here is 1, because sine squared plus cosine squared is 1. Which will tell me that we have 1 plus 1, which is 2 plus 2 sine theta over cosine of theta times 1 plus sine of theta. Up there. Questions on this here so far? Do we have a greatest common factor on top? 2, yes? And when we factor that 2 out, we get 1 plus sine of theta over cosine of theta times 1 plus sine of theta. Well, these will cancel, leaving us with 2 over cosine of theta, which is 2 secant of theta. Questions on this here? There's a lot of steps, but probably, hopefully, not as challenging as you thought it was going to be. Any other ones on this page that y'all want to look at? If not, that's fine. All right, that's fine.